Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to have a very special guest on today. I mean, very special because it's not one of my Siemens colleagues today, but it's Olivier. And I'm not going to sort of go into too much detail about his role because he'll introduce himself in a second. But we're talking about a really interesting topic. We're talking about industrial IoT, which I think many of you know we've covered on this podcast many times. But we're actually coming at it from a different perspective today, and it's actually from a sort of a developer's perspective, which is fascinating for me because I must admit I'm not too clued up on the topic from that particular perspective. So I'm really looking forward to the conversation. But if I hand over to Olivier first of all, just to sort of introduce yourself and what you're currently doing, and maybe a bit of your background as well, would be a great starting point.
Definitely. Well, first of all, Ruslan, thanks for having me here on the show. I really appreciate that. Usually I'm the one interviewing. But I like to be in that other seat as well. Let's see how you do. But
I don't know about that.
No pressure at all. So my name is Olivier Bloch. I'm an IoT advisor. I have my own company. I do work with different kinds of company in the medical space, in industrial automation, and others. And I also create technical content. My goal is to educate people on how to do IoT right. And my background is in IoT. I've been in the IoT domain for 25 years, as far as I can compute. I started as a developer. I was building real-time embedded systems, coding in assembly in C, C++, caring about timing, caring about synchronization of tasks and threads and all those kind of fancy things. And the main reason why I started my career in that domain was that I was not decided whether I wanted to do electronics or software. It was whether hardware or software in the school I was in. And there was this major that was created at the time I came into the junior year. And it was about embedded systems. And I was like, hey, I get to solder stuff and code software that's going to go on them. And it was really, really like the right middle ground for me. And I started doing that, did that for 7 years. And I specialized in Microsoft embedded technologies. So Windows CE, XP embedded, POS, this kind of things. Automotive as well, lots of work for Ford. And I was hired by Microsoft after my 7 years careers as a developer to be their technical advocate for developers in France. And did that for a couple of years. I had a good networking with the teams at Corp in Seattle, or in Redmond, more precisely. And they moved me to the US and the family. And so we've been living in the US for the last 16 years. And spent time with the Windows Embedded group at first. I joined the MS Open Tech group, which is an interesting part of my career because it relates directly to engaging with open source communities and how open source plays an important role in the industry at large, and we'll definitely discuss that later on. And I ended my career at Microsoft in the Azure IoT group, where I joined the team when it was at its inception and spent 7 years growing the team and growing an engagement team with developers. And the idea was for me to not only own technical aspects of the product, such as the open source SDKs for devices, but also owning that engagement, that interaction with the primary users of the platform, which were developers, the ones using the APIs, the SDKs, the PaaS services, and so on. And so I did that for 7 years. And it's been a year now that I'm on my own, telling people how to do IoT right, and trying to learn as well. There's so much to learn in that domain that's why I'm doing the IoT show, and I guess that's why you're doing this show as well. It's a lot about ingesting information. That's me in a nutshell.
Yeah, I guess we're the other end of it. We take the ingested information and share it, and then create the insights around that. Make some sense out of data. Well, I guess Senseye sort of makes sense. We keep saying the word sense.
Sure makes sense. Yeah. I like that.
But yes, let's start because it was interesting. You raised the question, Olivier, just before our chat. What is a developer? Which again, some people coming from different angles will have different views on it. But what's your sort of take on it as someone with your fantastic background?
Yeah, definitely. I told you, I think it's an important thing to do. Define what a developer is. What is that word as we use it, especially in the IoT domain? I think there are domains where it's easier to define. You talk web, you talk mobile app, it's easier to define what a developer is, right? They're building an app, interacting with a database, sometimes building a backend. And it's kind of easier to narrow down what the skill set are, what the specialties can become, and what the languages are, what the tools are. When it comes to IoT, because the technology spans all the way from the devices all the way down there on the sensors up to the cloud, you have to define what kind of IoT developer we're talking about. So in general, when I say IoT developers, there's an S because it's a team of folks that are with different backgrounds, different specialties, but have a common sense of what that end-to-end story is from sensor to cloud and can work together, interact with that common sense. And I think there's another aspect of the IoT developer, which is the fact that they have to build a solution in application code, whether for an operator that is in the field, on premises, interacting with the machines, with the sensors, whatnot, or with people in the business side of the story that will consume the data and the insights that have been generated and extracted from the data from the sensors and devices. And they also have to serve IT professionals who will be managing the assets, the machines, the equipment. So these developers, they have to understand the realm that these applications, the domain that these applications will be used in, what they are for, and they have to understand the users that are diverse. Once again, back to the mobile developer, they have to understand what a mobile user, like the consumer, is. Sometimes they have to understand what the consumer of that information, whatever is on the back end, that would be the business application that the company building that mobile app need to have. But at the end of the day, the IoT developer for me is everything in between. And that's something that is very broad. But sometimes you'll hear me saying embedded developer or cloud developer. And these are different members of that team that are creating these IoT solutions end to end. But as we'll see, it's even more complex than that. I think the fact that we have all these skill sets and expertise involved in developing IoT solutions is like super fun because you get to interact with lots of different types of people. But it also creates that not impression, that reality, which is it's complex. There's a complexity that is, inherent to all the IoT solutions and projects.
Yeah, and you mentioned sort of a wide number of sort of stakeholders involved and different viewpoints and stuff. And you mentioned something in your sort of intro about this vision of like doing IoT right versus wrong. So maybe we could sort of start the conversation there. I mean, what is doing IoT right versus doing it wrong in your eyes?
Yeah. So there's some basics. The reason why I started saying that I want to help people do IoT right is because of all the stories about IoT projects tanking at proof of concept. Like we see these numbers of like 70% of IoT projects that never moving on. And I was trying to scratch into the problem. Why is that? IoT is a great technology. We know it's feeding businesses with really insightful and important information for them to evolve their businesses. We know that it's going to feed AI algorithms. It's going to be the source of the real world, data for AI models and AI in general. So we know IoT is here and is here to stay. Maybe it was a different name. That's a different story. But IoT is here to stay. And so at the end of the day, why is it failing? Why are so many projects not going forward? And well, I had this lens that was the hyperscaler Microsoft one before I left the company. That was, hey, guys, like we're creating these really great services and no one is really understanding how to use them and leverage them. That was kind of frustrating. And that's why I was like trying to talk about what features were in these products so that developers could start using them and identify how they can leverage these features to extract value. And that brings me to that other lens, that was the customer's lens, that I realized, especially in the last year and a half, I already had a a hunch that this is what was going on. But the main reason, and I'm not the only one saying that, these projects are failing is because people started looking at IoT as this fancy little shiny technology that was like fun to light up an LED and fun to interact with your home, with automation. But the use of technology was not meant to solve problems. It was like, hey, we know we need to be connected. We don't exactly know why. We'll figure it out later. But there was never an actual goal, rarely an actual goal of generating value. There were a lot of assumptions that, once everything is connected, everything's going to be easy. There's another assumption that, hey, we have the cloud, so infinite compute, infinite storage, so we can send like every single bit of information. And not even realizing that, okay, we have all the data. What are we going to do with it? We'll figure out some, reasons for having all that data. And then people started realizing, but all of that has a cost. Sending the data, storing the data, having compute in the cloud, and that cost, is it outweighed by the value that this data and the insights I can extract are bringing or adding? And very often that was not the case. It was like, hey, we have temperature data up in the cloud. Okay, what are we going to do with that? Oh, AI. Wait a second, can I just put a threshold on that device and I don't need to do all of that? And that's going to cost me that much of sending all that data, and I don't need that, right? And so very often the problem has been that there was not an initial real thinking around what's the value we're going to extract, and is that value outweighing the investment in new equipment, in connectivity, in security, in cloud costs, and so on. And very often that's the conclusion after these proof of concept, which is like, hey, great thing, but the problem it solves doesn't save me enough money or doesn't add enough money in my pocket to justify that investment. And especially in industrial IoT, like, people are very pragmatic. Right? It's something that, that new device or asset is here to live for the next 10, 20, 30 years. And I cannot stop a production line for the sake of, maintaining something or changing something. You have to really justify what the value is. And it was very hard for many to justify the little Raspberry Pi project that was blinking an LED or doing some vision AI to pretend doing quality control. You had to really start from, the end goal that was the value. And I'm convinced, actually, I'm seeing firsthand that companies are starting to really realize that. And they approach IoT no longer from the fancy, buzzy aspect of things. They're approaching it from what's the value this technology is adding, and how is it solving my problems? How is it evolving my business to grow it? How is it changing my business model if I need to survive in a rapidly changing ecosystem and economy? And can I do it? Am I skilled? Do I have the budget? Can I invest in that? Do I have the time? So all these questions are now asked upfront versus after the fact. And I think that's what really is changing. And as we'll discuss, certainly, developers have a big role in making that happen.
So I guess a lot, because we experience similar things, really. So there's often too much focus on, we want this really cool technology. Oh, it's AI. Oh, it's Gen AI. Let's implement this technology without actually thinking about what are the business outcomes we want to resolve here or improve, and how we're going to do it, and where does it fit into our sort of overall picture? I guess that's the kind of thing you're saying, Olivier.
Exactly. I can't tell you how many times, especially lately, and like in that last year, of advising different kind of customers and that are at different stages of their investments or research or trial with IoT. I very often realize that, wait a second, well, first, why do you want to connect that asset or that device? Like, do you really need to connect it to a cloud? Like, do you understand that the implications for you to do that? Security, having to manage with provisioning and maintenance and life cycle of that device. Now you have a cost added to your COGS, which is, the cloud services. They're not free. And you're going to have to staff all of that. So why do you need to connect that? And very often I've heard, kind of like explanations, but I think that's where I help them a lot to start with, which is really asking themselves, do you really need to do that? Yes, it's fun to do it. Yes, it seems like your competitors are doing it, but do you need to do that? And if that's the case, then let's look at really what do you need? Do you need the big wall shebang thingy with everything, device management and security layers and whatever, or do you need something super basic? And then the second question that I'm usually diving into, especially these days, which is like, hey, we want to use Gen AI. Like, wait a second, that's not what you want to. That's not what you meant. Yes. We want to. So you want to talk to your machine and interact with that machine and talk about the weather and the philosophy and so on. And just like, no, what are you talking about? Like, well, that's what Gen AI is about. What you want is AI. What you want is specialized models. Sometimes they are language models, but they should be specialized and smaller because they need to be adapted to your scenario. But what you're looking at is boring AI, is AI that does something. It's AI that will generate, insights such as anomaly detection, such as, data for doing predictive maintenance. And the third question is, where do you want to run these workloads on? Like, you want to connect things because you want to share the data to run the workloads in the cloud. Do you need that? Do you need to send everything up for analytics up there? Do you know that there are ways to distribute that intelligence at the edge? Should it be on one of your servers that is on premises or on a smaller gateway device that already is beefy enough to run algorithms and models that will allow you to filter data, normalize the data, extract the insights, and so on? Eventually, I was talking to someone preparing for an IoT episode, and we'll have soon. You can bring AI all the way down to the sensors. Some people are optimizing models for doing anomaly detection, for example, to be able to run on few Ks of memory and storage. And these tiny pieces of code will do anomaly detection directly on the chip that is on the sensor. And now you realize that, oh, wait a second. So that means that I don't need to send all that data to a cloud service. I might be able to just send the insights of that sensor. Sensor has been configured to detect an anomaly. Instead of sending everything, I'm going to send the signal, hey, there's an anomaly here. And now my cloud service can react, can set up maintenance, interacting with the ERP and CRMs tools and so on based on that insight versus having to do the analytics, having to understand the data from all these sensors, having to deal with the diversity of devices and data formats and protocols and standards that are out there in the cloud versus bringing that intelligence down where it needs to be. And that's definitely the sort of question that we discuss with the customers. Where is that workload? Where is that intelligence running? And does it need to be running it all in the cloud, or should it be distributed, in between that edge and the cloud?
And do you think? Based on what you're saying there's a lot of complexities, and every customer and every deployment is different. Do you feel that customers are feeling overwhelmed by all these different options, how to do this? When should I do this versus this? And these kind of questions that sort of come up.
It really depends. That's interesting because, like, in the same domains, I've encountered companies that were very aware of what the technologies were about, what they could extract from them, and what to do, what not to do. But the majority is still, because they're focused on their domain of expertise. When you create a medical device, you're an expert in complying with the medical requirements and regulations. You are an expert in providing fine results for analytics on the endoscopes and the cameras and the sensors, right, that are related to the medical domain and space. Your data scientists are specialized in this kind of data, right? And so when you approach the question of, okay, my instrument that used to be pretty smart, that is pretty smart, now needs to be connected, right, and have patient data on that, and so you're telling me now I need to traverse a local network, which is an hospital network, usually pretty much locked down, to go to a cloud service. And now you're talking gibberish to that person because they don't know networking. They don't, and that for good reasons. They're not specialized in that. And so you enter into a level of conversation that is outside of their comfort zone. And so, yes, it appears to be complex for them because it's not their comfort zone, right? If we were to start talking about a hobby that we don't have that is not related to technology, we'd certainly find it complex, for good reasons because we don't know anything about it. And that's exactly the same for customers. And it looks complex because you have so many aspects, so many technologies involved. It's no longer about the embedded part, the device sensors, the hardware, the firmware, eventually firmware updates, and so on. It's about the networking. It's about the security. It's about the cloud. It's about the latencies. All of these aspects that they were not familiar with. One big one is like, what protocol should I use to communicate with that cloud entity, right? Should I go this way or this way? Should I use this platform there or this one? Should I go with this cloud provider or this one? All these choices make it even more complex. There's like such a diversity of an offer for good reasons. There's so many things to do and to be done that they are lost in that. And it's not because they're not good at what they're doing. It's actually because they're pretty good at what they're doing.
Yeah, I think, it's certainly a complex, a complex environment. And I get the other thing I was thinking of as well is just so many different sort of use cases for data as well and IoT. I mean, is there some that sort of come to your mind, Olivier, sort of key, ones, that are maybe not, currently trending, let's say, currently that you're hearing more and more at the moment versus others?
Yeah. So that's interesting. You're mentioning that. Someone recently, told me that the IoT problem was not the connectivity in the devices, but was the data pipeline. And I thought about it a little bit. I was like, you know what? At the end of the day, the data pipeline is where the gold is. That's where the value is. Is the devices the sensors will generate information that can be digested, used to take action, right? And so in that world of embedded and devices and robotics and industrial automation, you have this notion of sensors and actuators. Sensors generate the data. You analyze that whether locally or remotely, and it's not something new, right? We're talking about AI now, but that's something we've done for a long time. And then you take action, right? But then this data eventually can be useful for more than just instant action on the hardware, on the process, or whatnot. This data can be used for extracting insights, such as, the wear and tear of the equipment. Can I detect that a conveyor belt is starting to vibrate at a rate that we cannot perceive as humans? That equipment will detect the patterns over a long period of time to foresee a failure, to understand that you have to do that that preventative maintenance on that piece of equipment. That's what we call predictive maintenance, because we're predicting that something is going to fail. And so that pipeline of data is something that is complex to manage. How much of that data is coming from, here or there? What format are the different data sources in? How do I normalize that data? How do I send it and send the right part of that data up to the cloud? Eventually, should I enrich that data? Because there are some information that only the device will know about, like serial number of the device that generated that piece of data or whatever. So you will have to enrich the data as well. Then you eventually have to encrypt it, to send it over a wire. And then on the other hand, you now start having the same kind of problems, which is, okay, I'm receiving data from this factory and now from this one. And then I need to correlate that with my customer data. And now I need to correlate that with my maintenance team schedules when it comes to generating a ticket and so on. And there's another sort of problem that is happening up there. But data is definitely the key. Data is definitely that when you look at a solution, and that's something that works really well when engaging with customers, they understand that. They understand the data pipeline. And they might be lost in what's around it. How do you make it work? But that they understand. They understand database synchronization. They understand data normalization. One of the problem I mentioned rapidly is this notion of like different sources of data and information. As you well know, in an industrial setup, you don't have machines coming from a single manufacturer. And so data formats are different. And the information you get in there is different. I work in the US. Everyone talks in freaking Fahrenheit and inches and whatever. Like just that, I've seen demos that were totally off because the assumption was for me that, hey, everything is Celsius, and no, it's not. So the math is different. The meaning of that term, of that value is different. Yes, it's an easy transition, but it's a tiny example of what you see in the industry at a different scale. Another good example is like a dimmer. You would assume that a dimmer, electrical dimmer, is like two pieces of information, right? On, off, and a percentage. Well, go talk to ABB, Hager, Legrand. They all have a different definition of what a dimmer is, and they will all present different data sets to represent a dimmer. And you're just like, why is so? And because they have their own way of interpreting what it is. And so now you need to reconcile all of that, normalize all of that, to be able to build a system that will interact with these entities. And the core of an IoT system is to be able to interact with different kind of devices, entities, and so on, create a digital twin of this set of entities that is usable, that is meaningful, and that is something you will have your digital application solutions interact with. And that digital twin, to me, is a good way of representing what an IT solution looks like or is in reality. It's a set of complex different things that you need to rationalize to be able to interact with and to have all of these work together. It's complex.
It is complex. And I'm thinking, there's a word that was sort of springing to my mind as you were speaking then. It's about sort of standardization. That's really what we need and how easy that is. But my other point I was going to make, and I've written down here, is around, it's not just about one person can't solve, or one company, I should say, not person. One company can't solve everything. So Siemens can't solve everything. You can't solve everything. It's about sort of a part, and actually, Siemens, we have Accelerator, which is basically like a combination of partner product, Siemens product, to offer, one solution to the customer, which is a really, interesting viewpoint. But would you agree with that assessment? And I guess my second question to that is, what are the challenges of working with, different partners on different parts of the process and bringing one solution to the customer?
Yeah, collaboration is definitely key in the industry, and even more so since different types of technology now are mixed and mingled, right? You have networking, you have embedded, you have security, you have cloud, you have all these domains are now like having to work together. And you have another aspect of things, which is companies want to make business. And one way of making business often is to try and retain your customers around your own ecosystem. So you create an ecosystem. I was mentioning, the dimmer scenario. Home automation is one domain where you can see what we call, the walled gardens, the domain, the ecosystems that are being built to keep customer in. Once you're in, it's super hard to interoperate with something on the outside. But we know that longer term, that doesn't really work. There are regulations that prevent being in a monolithic state, in a dominant position like that as a company. And so you have to diversify, you have to interoperate, you have to interact. And at the end of the day, that's the way things will evolve and will grow. Innovation can only happen when you have these bridges between, competitors, because the winner at the end of the day is going to be the customer. So I'm kind of like going on a tangent here, but you do need collaboration, and collaboration happens around agreeing on how you define things, how you exchange information. And we're back to the data pipeline. The data needs to be normalized. You need to have a common definition of what things are. And there are so many ways to do that. And I think the debates that are out there are no longer about, should we have interoperability? Should we work on standards? That's a no-brainer. Everyone understands that we do. The big debates are around what level of the technology stack should this be done? Some people will argue it has to be done at the protocol level. It's something we need to agree on the protocol, and what goes on the wire doesn't matter. Everyone can do what they want. Some other people saying, hey, we want to, like, a good example is unified namespace in industrial domain. That's a very opinionated approach to try and unify data. It happens at a protocol level. And it leaves to the different manufacturers to define the upper level, which is really the detail, the fine grain of, what is that device exposing as data. What you want to agree on is what's going to be the method for this device to expose the data, and all agree on the fact that we're not going to use 10 methods for discovering and for doing the handshake and things like that, right? So it's almost a protocol rather than an actual, high-level standard. Other ones are looking at digital twins. Like, should we have a language for describing digital twins? Should we have a common way of putting a JSON file in format, in a schema that everyone agrees on, so that every single device that comes on the network declares its capabilities in that format, and that everyone can understand because everyone talks the same language, basically. Other people will think it's at a higher level. It needs to happen. We need to define and standardize what a dimmer is. What a robot arm articulation is about. What a conveyor belt is. And so they try and be more opinionated. In the realm of home automation, Matter is an example of that. They're trying to define, what a switch is. And have one way of doing it, and tell everyone, hey, you're a switch. If you're a switch, all good. You have to expose your functionality through this set of APIs. If you're not this switch, then you have to create a new version of the switch that's going to be called switch 2, whatever, right? And then you say, hey, I'm switch 2. Eventually, I inherit from that switch 1 and have this functionality plus more. And so that's another level of, I would say, standardization that's happening. And I don't think there is one answer to all the problems, right? It's so diverse. But converging on these different, in what we call industry standard, and then putting in place regulation that enforce people to use them, I think is a good way to go. And I can hear some people like jumping at me for regulations. We don't need that. Don't do that. But actually, it helps. It helps a lot because, especially in domains like security or privacy, you need to have regulators, come into play, because they are kind of like the cops that will be sorting things out and say, hey, no, like, stop that. That's a mute debate. You're just fighting over something that is useless. So let's define what it is and go with that. We'll evolve that, together. But here is how things go. And I think the industry is definitely leaning towards building these bridges and agreeing on what they are and what they should be. And so we will see more and more standardization, but there's not going to be one IoT standard, because it doesn't mean anything. It doesn't, like, when you say one IoT standard, is it like the protocol for communicating between device and cloud? Is it the security layer? Is it the way you define a device? Is it the platform APIs? There's no such thing as a standard there. It's a collection of technologies that are being standardized because they are recognized as the best way of doing things in a specific part of this domain. Does it make sense?
Yeah, no, it does. It absolutely does. That's such an interesting topic, because I know another area we were going to talk about is sort of open source contributions as well. And it's because you mentioned security and things like that. I mean, where do you see that sort of fitting into all this?
So I mentioned that I spent 3 years and a half in a subsidiary at Microsoft called MS OpenTech. So that was 12 years ago. And the mission of that subsidiary was to understand how open source ecosystem could advance standards. And the reasoning around that was very simple, is that for a standard to be adopted by the industry, it had to have a certain number of implementation from different vendors or different entities. And open source communities and ecosystems are considered entities that would build implementation of specifications that could become standards, right? So open source communities can move forward standards and allow for this bridging between vendors in specific technologies. And as a side effect, we learned a lot about how important it is to open source code so that the industry at large can start trusting more what's in that code and not just trust a black box that is getting bigger and bigger and having more and more holes to it. So now you open source, and that gives more robustness to your code, more visibility to the customers that can start also contributing to it. And so the realization has been, for me at least, but lots of way smarter people, already knew that, and that's why they created that subsidiary. That open source plays a key role in bridging different vendors, different domains, different technologies, and IoT is no exception. IoT needs open source at different levels to advance, innovation. A good example is open source hardware. Hardware is something that's been closed sourced by culture for a very long time. Some came in and revolutionized that, saying, "Hey, wait a second! Like, there's no reason to have an IP on, this electronics montage or whatever. It's something that we should just release as open source because everyone can benefit from leveraging that architecture." And as much as software architecture, once everyone agrees that this is the best architecture, then, let's move on to the next topic because that is sorted out, that is solved, right? And software, same thing. So many different protocol layers that needs to be standardized. If you push open source implementation for standardizing the way things are done, for example, leveraging JSON to formalize, to normalize and format data coming from devices, right? Using MQTT as a protocol that would be the best candidate for machine-to-machine communication and brokerage of information between different entities on an IoT network. MQTT is not the only protocol out there. Is it the best? The debate is still open. But because there are many open source implementation for clients and brokers, its adoption has been accelerated because people didn't have to reinvent the wheel or to use some proprietary piece of code that had a cost. They could try out different options out there of different brokers, of different clients, and they could advance the adoption of that protocol as the de facto protocol for this domain, right? And so open source definitely accelerates innovation, and it's been demonstrated so many times. Should everything be fully open? I don't know. I mean, that's something that doesn't have any absolute answer. There's still IP in there. There's still things that you can innovate on and be the only one doing so in a domain that really adds value. And so, do you want to open source that? From the business perspective, that might not always be the best idea. But for the area of bridging, of interoperability, I don't see how closed source can help. Open source is a way to bridge different domains, different worlds, different vendors, different technologies. There's no other way because you have to collaborate. And so collaboration can only happen when there's transparency and when there's direct access to what's under the hood. And that's what open source is about.
Exactly. No, that's interesting because I wouldn't, someone who's not versed in the terminology, I hear open source and wonder what it means. But that's interesting. Sort of changed my perception of that, which is interesting. But exactly for what I thought it was. But yeah, so I guess we've had a really great conversation. I'll admit to the audience now that it's sort of gone in a bit of a different direction to what we thought. So it's going to be much more developer sort of focus. But actually, I think it's gone in such a great direction. I think we could do a whole new podcast on what we were originally going to talk about.
But you should realize, Niall, that developers were infused everywhere in our conversation. Developers have a role to play at every single stage of that conversation. When we talk about open source, the ones driving these projects are developers, right? The one defining the directions of these developers usually is a small committee of developers who are very much involved in this piece of software. Hardware, same thing. Hardware developers are involved in the open sourcing of hardware, architectures. When it comes to standards, implementations are made by developers. When we talk about bridging technologies, developers collaborate, developers from the realm of the cloud, developers from the realm of the networks, the ones from the realm of security, they all have to collaborate together for things to work. Because it's good to have an architect deciding that this thing should work with that thing, but who's going to make it work? People implementing the software that's going to run on a device, that's going to run on a gateway, that's going to run in the cloud, that's going to run in a mobile device companion app for provisioning, whatnot. And developers have to go talk to the operators. They have to go talk to the final customers, etc. So, like in every single conversation or questions that we discussed today, developers are part of the story, and that's usually my word about developers. That they're very important because they are everywhere, and they have a decision power when it comes to picking a technology, picking an implementation. That is great. That is pretty important. There's no such thing as a decision maker sitting on his own at his desk and making the right decision for everything from edge to cloud in the IoT domain. I don't know if it's even possible in other domains, but in this one, even less so. And so developers are involved in conversations, they're involved in decisions, and they are key to advancing innovation and to advancing these standards, these bridge between technologies. And so they'll be key to making IoT robust, pervasive, as it should be, as it needs to be for not just the sake of our domains, but like all industries, because IoT is here to power pretty much everything, being the invisible electrical and plumbing behind the walls of your house. That's what IoT is for industries at large. That thing that is an invisible technology that just works and provides data, provides information, provides control, and that's what IoT is about.
Exactly. I couldn't put it better myself. But I think, I think that's a nice way to sort of finish off the conversation, Olivier. But like I said, we'll definitely come back for a follow-up episode, focusing a lot more on the developer side. I think I'll dive into that topic a lot more. But I guess for now, if people want to sort of find out more about you, keep up to date with what you're doing, what are the best channels and places to do that?
So the IoT Show is the name of my YouTube channel where I talk about all the things, and I guess we can put my LinkedIn profile somewhere as well. That people can go and search for it. Olivier Bloch is the name. I'm definitely happy to engage in conversation about all these topics. Also help customers figuring out how they can implement IoT, and at the end of the day, also happy to engage in conversation around how we all make IoT right. So that way we're not into all these crazy stories about security, about failed POCs. We don't hear about failed plumbing in a building these days, right? Because things are robust enough and standardized enough and regulated enough so that you don't have that. So we'll get there with IoT as well. There are very robust solutions out there that interoperate really well with the rest of the world. There are so many options, though, to navigate through that you might need to have someone helping you navigate all of this ecosystem. And that's where people like me, like you, try and help, which is helping people decipher, understand better, weed out, and identify what will work best for them and for their goals. Back to the initial question, to make sure they focus on what their ultimate goal is and what is the problem, what is the use case they're trying to address, and not have to focus on the technology itself. Technology is a means to an end. So they need to work on the end.
Yeah, no, exactly what we talked about at the start. So that's nice it's come full circle on the business outcomes, not the technology first, outcomes first,
Exactly.
then solved by the technology.
Exactly.
Yeah. So that's brilliant. So, thank you again for joining us today, Olivier. And like I said, I'd love to invite you again very soon because I think there's a lot more we can dive into in this topic. But for today, thank you for your time. And thank you, everyone out there, for listening. And we'll see you on the next episode.
Bye.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.